Okay, now I think the family challenge we set on Friday was particularly difficult. So I thought what I'd do is I will go through the answers to the questions and explain them as best I can. I will admit that there was one question in particular I found very, very hard, and I did have to seek advice for it myself. So don't worry if you found some of the later ones really, really hard. Okay, for challenge 1, okay, what we're looking at, we've got several pieces of information here. So we've got 2 stars here, and they equal 20. So what we've got to do is, okay, something shared equally because they're both the same thing. So 20 divided by 2 has got to equal 10. So each of those stars is worth 10. Now, if we know that a star is worth 10, at this point we can say, okay, that star has got to be worth 10. So something take away 10 equals 7. What take away 10 will equal 7? Well, it's got to be 17. Okay, now I can also say here that heart must be 17 and that heart must be 17. So 17 take away 17 equals triangle. What does that actually equal? It equals 0. So that triangle must equal 0. Okay, question 2. So we've got Tom with his 6 10p coins, 3 5p coins. He's buying an apple and 2 pencils. How much does a pencil cost? So we need to work out how much he's got. So we have got 6 times 10, which will give me 60 pence to start off with. And then he's got 3 times 5, which gives me 15 pence. So in total, he has got 75 pence to spend. Now, we're trying to work out actually how much he spent on pencils to start off with. So to do that, we're going to get rid of the 59p. So I've got 75, take away 59. So 5 take away 9, I can't do, so I'm going to exchange. 15 take away 9 leaves me with 6, and 6 take away 5 leaves me with 1. So in total, 2 pencils cost me 16 pence. Now we're trying to find the value of 1 pencil. So all I need to do is 16 divided by 2, and the answer is 8 pence for 1 pencil. Okay, challenge 3. So it says, here are some digit cards. Amir and Donna each make a 3-digit number using all the cards. Amir notices that when he subtracts his number from Donna's number, he gets an answer greater than 300 but less than 400. What numbers did they make? Now, there are a couple of different ways of doing this, but basically what we want to say, we need to start with Donna having a high number. So her number is going to start with 8 in the hundreds column. Okay, now we need to be able to get this. So if we put that down as Donna and Amir. Okay, we need to get this so that we're bringing it down far enough, but not too far. So Amir, we've got to get it between 300 and 400. So Amir is going to probably start with the 5. Okay, so we've actually dealt with those. Now, you could sort of rearrange the numbers in different positions, really. So let's start with Donna having 853, for example. So you can pull the numbers out your hat, really. And maybe Amir has 538. Let's see what actually happened. So 853, take away 538. Okay, so 3 take away 8, I can't do, I've got to exchange it. So 13 take away 8 leaves me with 5. 4 take away 3 leaves me with 1. 8 take away 5 gives me 3. So is it between 300 and 400? Yes, it is. So that would be a correct answer. You could have tried Donna with 835 and Amir with 583. So let's give that a whirl, see if that turns out. So 5 take away 3 gives me 2. 3 take away 8 I can't do, so I'm going to exchange. It leaves me with 7. 13 take away 8 gives me 5. 7 take away 5 gives me 2. So that wouldn't have actually worked. That wouldn't have been a possible answer. So starting with logic, we look at the logic of the digits in the hundreds column, and then we can play around from there to actually see what works. So this was your correct answer. Okay, so challenge 4 is all about using logic. So we know we've got 5 identical rectangles are put together to make a large rectangle. The width of one rectangle is 4 centimetres. This is demonstrated to you on the diagram. Work out the perimeter, so the outside space of the large rectangle. So if I'm doing this one, I'm going to label everything. So I know that this part here is 4 centimetres. That bit is 4 centimetres. That bit is 4 centimetres. Now, how am I going to be able to work out the longer side? Well, if you look on the inside of our shape, I know that that is 4 centimetres, that is 4 centimetres, and that is 4 centimetres. So if we're looking at it, this whole space going from here down to here is the same as 3 lots of 4 centimetres. 3 lots of 4 centimetres is 12 centimetres, so I know that is 12 centimetres. Therefore, our rules about rectangles are opposite sides are the same, 12 centimetres. That must be 12 centimetres, and so must this, and so must this. Now, there's a lot of information going on there. You've got to work it all out. So, using this to help us. So 4, add 12, because we want to work out what the whole of that side is. So 4, add 4, add 12. 4 add 4 is 8, add 12 is 20 centimetres. So I know the whole of that side is 20 centimetres, and the whole of that side is 20 centimetres. So now I can do my addition. I've got 20, add 20, my 2 longer sides, add 12, add 12, my 2 shorter sides, 20, 20, 12 and 12. Okay, add it together, so 0 add 0 is 0, add 2 is 4. 2 add 2 is 4, add the 1, add another 1 gives me 6. So the perimeter is 64 centimetres long. Okay, now I will admit that when I started working this one out for the first time, I actually made a bit of a fundamental error, and I couldn't get it to the right answer. I will admit that somebody pointed out what my mistake was. I have now been corrected. So if we're looking at this, we've got 15 identical blocks lined up as shown. The length of each individual block is twice the width. If all 15 blocks are then laid end to end, what is the total length of the blocks together now? Now, the mistake I made was I looked at this and I said, oh, it's 15 blocks. I've been told there's 112 centimetres. I'm going to divide by 15. But I didn't look at the whole detail on the question, which is what I'm always telling you to do. What it actually says is the 112 is the same as 1, 2, 3, 4, 5, 6, 7 of those blocks. So what I've got to do to work out the width of one of them is 112 divided by 7. So 7s into 1 don't go. 7s into 11 go in once, which leaves me with 4. 7s into 42 goes 6 times. So one block is 16 centimetres wide. Okay, so that's the first piece of key information that we've got. Now, the length of each block is twice the width. So if each one of those is 16 wide, I've got to do 16 times 2, which gives me 32. So each one of those blocks is 32 centimetres tall. Now, then I can apply this to the rest of the problem. So each one of these is 32 centimetres. Now it's been just turned on its side, they're going length. Now I've got 15 blocks. To find out the total length, I need to do 32 times 15. 2 times 5 gives me 10. 3 times 5 gives me 15. Add the 1 gives me 16. 2 times 1 gives me 2. 3 times 1 gives me 3. Add it together, so 0 add 0 is 0, 6 add 2 is 8, and 1 add 3 is 4. So the total length is 480 centimetres long. Challenge 6 is all about what is the same and what is different. Okay, remember we've done this quite a bit in class where we're thinking about how we spot similarities, how we spot differences, and how we can use that to benefit us. So we've got these 3 shapes, and we've got to work out the total of this shape. Now I'm going to number them so that you can see which one I am talking about. So I'm going to call these 1, 2, 3, and 4. Okay, now the way I'm doing it, you might have come up with a different way, but the way I'm looking at it is I'm trying to see what is the same and how I can calculate things from it. Well, if I'm looking here, I need to work out, I know the total of this bit. This section here on number 1 is 15.6 centimetres. So I know that part of this is on question 4, or section 4, is 15.6 centimetres from there to there. but I need to work out my cylinder. So from here, I can do that. Now, what I'm going to do is I'm going to add up numbers 2 and 3. So number 2 is 18.3 and number 3 is 13.9. Now, the reason I'm doing that is when I've combined them, I will have made sort of a new shape with a cube, with the hexagonal shape and 2 cylinders. Now I can use the fact from number 1 that I've got a cube in this hexagonal shape to actually help me. So I'm going to add that together. So 3 plus 9 gives me 12. 8 plus 3 gives me 11. Add the 1 gives me 12. And 1 add 1 add 1 gives me 3. So I've got 32.2 is the total of number 2 and number 3. Now I've got to get rid of the value from the cube and the hexagonal shape. So I am going to take away 15.6 from there. So I've got 15.6. So 2 take away 6 can't do. So I'm going to exchange. 12 take away 6 gives me 6. 1 take away 5 can't do. So I'm going to exchange that. So 11 take away 5 gives me 6. 2 take away 1 gives me 1. Okay, so that has left me with 16.6, which is the value of 2 of these cylinder shapes. So to find the value of one cylinder, I'm going to do 16.6 divided by 2. So 2 into 1 doesn't go. 2 into 16 is 8. And 2 into 6 goes 3. So I now know that one cylinder is 8.3. So I can add that to the 15.6. 6 plus 3 gives me 9. 5 plus 8 gives me 13. 1 add 1 gives me 2. So my answer is 23.9. Challenge 7. Right, this one again is a little bit tricky, and my solution to it might not be the best mathematical solution, but it got me to the right answer. Now, if you're looking on the sides here, I can see that that side here, because I've got these little lines, it's telling me that they are all the same length. So this bit here is the same as this bit here. Okay, as the same as this bit here, and is the same as this bit here. Okay, now that is going to help me because it means I can actually break it up into a grid. So what I'm going to say is, if I draw a line straight down here, and I draw a line straight down here, I split it up. But I also know that this section here must be the same size as this section here, so I can actually draw a line straight down there. Now I know my lines aren't particularly straight, but you know what I'm trying to do. And I can do exactly the same over here. So I can split that, I can split that, and I can also split that. So now I've actually got a 4 by 4 grid. I know straight away that I've got 4 by 4 grid. Now 4 by 4 gives me 16. So 4 times 4 gives me 16. So if I'm looking at this and turning it into a fraction, which what I need to do, because that's what you're looking for, is going to be something out of 16. Now this is where it gets slightly less mathematical. But what I'm trying to do is look for whole squares. So I've got 1, 2, 3, 4, 5 whole squares. But actually, if I put these together, that would be a 6th. These two. Put these two together, that would be a 7th whole square. Put these two, that would be an 8th whole square. 9, whoops, that's not really a 9. And that's a 10th whole square. Not exactly perfect, but you can see actually the shapes pretty much work. So I've got 10 out of a possible 16. Now hopefully you can all see from that I could simplify it. So if I do 10 and divide it by 2, because 2 goes into both of those, 10 divided by 2 gives me 5. 16 divided by 2 gives me 8. So the fraction I was actually looking for is 5/8. But if you got 10/16, then you still got the correct answer.